compensate for that aberration in GFR. Okay, so the setting is, let us assume that GFR all of a sudden just went up. The renal plasma flow didn't change. So in other words, the filtration fraction went up. Yes? So what will happen? One thing that's not mentioned in this diagram is if the GFR goes up, then PT goes up, right? Tubular pressure. If the GFR goes up, then P cap, the hydrostatic pressure in the capillary, goes down. Yes? So in other words, you filtered more, there's less goes this way, and so the capillary hydrostatic pressure goes down. Now, if we filtered more, we concentrated the proteins more, yes? So the pi cap goes up. So the GFR went up, and let's see how the forces affect reabsorption. That went up, that will enhance reabsorption, yes? That went down, that'll enhance reabsorption, yes? That went up, that'll enhance reabsorption, yes? Okay. So, and I hope it doesn't seem like smoke and mirrors, but it's in textbooks, and they kind of ask you to be able to understand this process. So that is glomerular tubular balance. The idea is that any change in GFR tends to be compensated for by an increase in reabsorption, such that in the proximal tubule, you'll always reabsorb something like 65% of what's filtered. Okay? Glomerular tubular balance. Okay, I think that's all I need to do there. So, talking of smoke and mirrors, I got one more page. And I want to use the same principles to do something just a little bit different. So, and I'm going to call it an override to glomerular tubular balance, just to try and put it in perspective. Let me set this up now such that instead of the GFR going up, I don't know whether I can use the same diagram or not, or whether I should do a new diagram. So in this case, let's just go through volume expansion. So we have a volume expansion, and it would make sense if you have a volume expansion that you want to pee more. Okay? So you get a volume expansion that will tend to increase the renal plasma flow, and here, and this is the kind of smoke and mirrors bit, we're going to say the GFR stays the same. And I don't know whether I want to use this same diagram or not. Let me just use the diagrams that are over here. I don't know, can I? Let's see. Should I use the same diagrams that are in the handout? Yeah, okay. I try to be faithful and use the diagrams in the handout wherever possible. So, is it on the left or the right? Yeah, the left. Okay. So this is the lumen, and this is the peritubular capillary, get a different color, red, different red. That's better. Okay, so we've increased the renal plasma flow. And here's the lumen here, but the GFR stayed the same. So if we increase the renal plasma flow, then the hydrostatic pressure here will go up, yes? So P cap will go up. What will happen to the oncotic pressure? So if we filter the same amount, and we have more renal plasma flow, we've diluted the proteins less. And so pi cap will go down. Yeah, down. Okay. So in both cases, and I think that's all I've put in, right? Yeah, that's good. So in both cases, this going up and this going down will tend to hinder reabsorption. And this is directly out of Costanzo, by the way. And so what we've done is we've got a situation where we have volume expansion. If we maintain the GFR, the increased renal plasma flow will tend to hinder reabsorption, and so you pee more out. Okay. Yeah, I know. I feel obliged to go through it because it's in the textbook, okay? But just, I mean, if you can just work with the concepts, I think we're good to go, all right? Let's see if there's anything else I wanted to add. Oh, I would just add one small thing. The reality is that actually probably the GFR the GFR will probably increase a little bit, okay? But even so, if it stayed the same, that would happen. And if it goes down just a little bit, that would actually enhance that process of getting rid of more stuff, okay? So, it is exactly 10 till, and it is kind of yawning time. And so I'll start to wrap. That is the last page in the handout, right? Yay! Any questions? Tomorrow we do the exciting stuff, clearance. Have I convinced anybody? Okay, thank you.